We want to be able to trace between ALM and PLM requirements. So if we go left to right here, the first thing we want to do is be able to link and trace. That means if you are a product engineer in the middle of Windchill, you want to be able to, from the middle of Windchill, go look at a requirement in Codebeamer and create a trace link to it. Likewise, if you're in Codebeamer, you want to do the same thing. From the middle of Codebeamer, you want to create a trace link to an object inside of Windchill. Not only that, you want to know if something happens to change. So if a requirement changes, me as the engineer inside of Windchill, I want to know that a requirement changed so that I can go make sure that my design is still going to cover that requirement. Likewise, if I'm in Codebeamer, if a change happens in Windchill, I want to know so that I can, again, from my side, make sure that the design is going to cover the requirement that I've specified. So this is foundational functionality that we're creating between Codebeamer and Windchill. In fact, a bunch of other ALM tools. The ability to link and trace so that you can know when changes happen so you could react appropriately to them. Now, in the next pillar, we start to move to something more proactive. The idea of enterprise change governance and management and configuration management. So rather than you being in the middle of Windchill and being surprised that someone changed a requirement, we much rather have that in a well-orchestrated engineering change process where someone is running an engineering change between, let's say, Codebeamer and Windchill to have a deliberate and controlled, let's say, change process that we can adapt and then we can have flow down through the entire system. And then, of course, we'd be able to have better reporting, better history reporting between these two things. So these first two pillars are very, very important to us to make sure that we start to get the process under control so that we could have requirements traceability from ALM to PLM. Now we start to move to the next pillar where we're starting to think more about it from a top-down perspective. So think like you want to start with a systems engineering point of view of your product line. Then you want to have a variability point of view with product line engineering. Then you want to use those two things to drive things across requirements, the development of software, mechanical hardware, electronics hardware, electrical hardware, and even hydraulic hardware, so you can have a much more top-down approach to overall design of a medical device system. And then, of course, the ability to do change management and link and trace is all foundational to do that top-down design. Now, the final pillar of our vision here is integrated simulation, so that you could do a simulation across all of these systems from software to all of the hardware that I just described, and you could do that in a virtual environment and do frequent builds. So the goal here is to actually bring agile product development across the development of software, mechanical hardware, electronics hardware, electrical hardware, and hydraulics, and bring that all into an agile process. Now that's our vision, but on top of that, because we're talking about med tech, this also is part of this idea of sweeping up the quality and regulatory reporting requirements so that we can link and trace these requirements all the way from their inception, all the way out through their verification and validation, and then, of course, be able to report to regulatory authorities.